Okay guys, let me run you through the rules of indices here. More of an algebraic approach. It's only an illustration though, but it's more an algebraic way of illustrating it. Okay, so you got the first one, times you add. Here's the phrase. So this section deals with more algebraic problems. So let's have a look at this rule, see if it holds then. A to the m we can write as a times itself m times. There it is there. A to the n is a times itself n times, isn't it? And when you tot up how many a's you've got all times together, you realize there's n plus n of them, which we write as a to the power m plus n. So that illustrates there, that little line there illustrates the general rule of times you add. So that's the first rule, so we denote that as the first rule, yeah? Let's go on and find some more then. What about divide? Well, I've put divide you minus top take bottom, okay? Here's what we start with then. Let's have a divide problem with indices, a to the m divided by a to the n. Here's the m lots of a, and here's the n lots of a. And then when you cancel them out, it's just an illustration. You'll be able to, you cut away n of these m. So you're left with the difference on the top here of m minus n, aren't you? You're left with that difference, yeah? So that's illustrated there. So we can write that rule in general then. We can infer this rule that a to the m divided by a to the n equals a to the m minus n. Okay, we'll label that as rule 2. Now if we use this and suppose that holds in general then, as a general rule, we can infer a couple of other little rules. Like for example, a to the 0. The 0 you can write as m minus m. And you can write this, because using this rule here, of divide you minus top take bottom. This is a minus, so you can write it here in reverse. Divide you minus top take bottom, so it's a to the m over a to the m. And this is nothing other than the same top and bottom, so that's 1. So we can infer that a to the 0 must be 1 then, if these rules hold in general. And what about this rule here? It's illustrated here. We can write minus m as 0 minus m, can't we? And use our division rule, and suppose it holds in general. It's a to the 0 divided by a to the m. Yeah, that's where we can go. Because that's divide you minus top take bottom, 0 take m. 0 take m. A to 0 is 1, a to the m is underneath. So basically, here's the rule here, the fifth rule I've labeled it here. When you move a number to an index from underneath to on top, you have to flip the sign of the index. So whatever number that is, that's flipped. And if you want to move it down to underneath, again, you have to flip the sign of the index, yeah? So that's that rule. Now there's one more rule to do, and that's power rule u times. So here you've got a to the m to the power n. So let's write out all those terms. Here's the a to the m, all the way along a to the m, and there's n of those, aren't there? So let's write them out long-windedly. We've got m of these, m of these, m of these, and all together there's n. So there's n lots of m, aren't there? So it's a times itself, mn times. So we can infer this rule then, power u times a to the m times a to the n equals a to the m plus n. So that's it, that's the third rule. So there's these 5 rules then, all illustrated here for you. And we should be able to go through the problems now, invoke these rules, and solve this section of problems. Okay then guys, all the best, and I'll catch you again. Cheers!